All right, so we're kind of continuing on with the bash shell right here. And we've talked about shell variables, and today we're going to learn how to kind of create them. And then, of course, we've already talked about how to reference them and then just more things about them. One of the first things that we need to understand is some of the restrictions that are in place. So you can see when we actually create shell variables, they must consist, or they can consist of letters, digits, and underscores right here. But it's important to understand that when it comes to actually at the very beginning character of it, only letters and underscores. You cannot use digits to start them out there. And we also need to understand that there are several special characters right here. And so these are some common ones right there. So we can't include those special characters because they have special meaning in bash right there. So we have some examples right here. A76, that works. My underscore cat works. And even underscore underscore X and so on. All of those are valid variable names. So y'all tell me, first one, is it valid? All right. Second one.
No.
Why?
Numbers.
Numbers. Perfect. What about third?
No.
Why?
The dollar.
Perfect. What about this one?
No.
At symbol. Perfect. What about this one?
Yes.
Perfect. All right. What about this one?
No.
Why? Dash. All right. So if I had this, it would be okay, right? All right. So that's one of the things I would say most people will get confused, that dash and underscore right there. That can kind of get you if you see that on an exam. All right, so we've kind of talked about global variables, or actually kind of like system variables that are already there, but we can also create our own variables. They're just simply called the user created variables. We can create these, change their values, set them to read only. We can make them global, just like how most of the system variables are. We can, of course, declare them read only, so they cannot be edited whatsoever. And it really is read only. Once you do that, they are there. Of course, we'll talk about how we can get rid of them. But at first glance, it looks like they're just there to stay. Right here. So again, we got the kind of the global and the local variable right here. So a global variable, again, parent can pass to child. The local variable, parents cannot pass that to their children as they are local to that shell right there. And again, both of these, the child cannot pass back to the parent. That'll never happen. You can't go in that direction right there. And of course, we kind of have the best practices. If you're lower or local variables, it should be a lowercase or mixed case, and then global variables should all be uppercase in here. Of course, that's just, again, a best practice. You can break that practice and it works fine. So when we declare it, we can just simply use this right here, name equals value. Make sure that there is no space. So that is important. If you put a space right there, it does not work. So here we have some of our examples, and then we'll just go into the shell and create one real fast. So if I just said person, and we'll just say equals max here, and then how would I reference that? How would I actually get the value or see the value on the shell? Anybody? What you got?
Dollar sign, quotation, curly braces, person.
What would I put before that? Echo, perfect. All right. And you pointed out a good thing. So I can do it two ways. You actually pointed out something I was going to make. So that right there works. Or like he said, we can do the curly braces. It's the exact same thing. We will find out today, actually the importance of those curly braces, because they do have some special meanings. But either one of these will work. You can use them anytime you want there. It's that this one will give you some additional features. All right, so there's a lot of keyword variables that are built into the system. You kind of have to be careful about using. We've seen home. Path is extremely important. You can kind of mess up your system if you wind up overriding that. And then we've got these positional and special parameters. So the positional, they're just numbers. So you got $0, $1, all through the nth number, and then we have several specials. This is not, we'll see more and more kind of build them up right there. $? That is going to be the success or failure of the previous command. So kind of the status of that command. $, that actually counts the number of positional parameters that were supplied to a script. And then I think I've shown you dollar right there. So that will be a process. So we could actually see what, if we actually type echo dollar, it's going to be the shell, the actual process ID number of that shell. There's lots of them. And again, we'll cover them throughout this semester here. All right, so in here, just kind of giving you examples right there, echo dollar user, we've seen it, the home, and then the path right here. We will see path a little bit more in here later, and we'll manipulate that. Now, when it comes to actually creating variables, I've shown you, we can simply, create it this way right here. And then we could also use a declare keyword. Don't get too confused on this stuff. You can do it both ways, and we'll see an example of using an actual declare keyword here in a little bit. Let's see if there's anything else on here I want to point out. Oh yeah, so right here, you can obviously see I'm using the $ to get person, but if I type person, then of course I'm getting just person right there. All right, now this one, we have a good example to kind of show some of the things, actually show the concepts a little bit better right here. So I'm going to set up in a few files here. So I'm just going to use the touch command, and then I'm going to use those curly braces right here because I'm going to create multiple files with the same extension. So I'm going to say Joe and Max, and then let me move that down a little bit so it's not in the way. And then I'm going to create I think it's summary here, nope, report. And then I'm going to create another file and just do max.summary. So again, this would create Joe.report and the max.report, and then we got max.summary here. So now if I do ls, you can see I have those 3 files. Now, let's see, I'm going to create a variable called echo, or not called echo, called memo. The first thing I'm going to do is just check for its existence. Of course, right here, we can kind of see if it does exist, at least doesn't have a value. So I know that I am good at creating this memo, and I'm going to set memo equal to max. And again, if I was to do that, that would be wrong. Hit enter. You can see it doesn't know what I want to do there. So I'm going to clear that screen, go back up here, and we'll put max. But I'm going to give it a wildcard this time, and I'm going to create, give it the value of max star there. So now if I was to go in here and just say echo $max, or sorry, $memo, what do y'all think I would get back? What do you think shell is going to put out? Create a memo. I set the value to max star. What happens when I hit enter?
Max star report and
Ooh, that was pretty good. Yes, that's what's going to happen right here. The reason why is because I put that wild card. We all know the wild card expands to match. So since the value was max and then the wild card expanded, it went ahead and picked up. Okay, well, there's you must have meant these files in here of max.report and max.summary. Now, I want to show you something that's really unique here. And that is if I do that, oops, not that. What do y'all think I'll get then? Not the same thing. We get something different. We get the literal value. The next slide, we're going to actually break that down, but this is kind of, I told you, it's going to be very, very important about the single quotes, no quotes, double quotes. All those have different meanings. And you're pretty much good to go most of the time at what you want. 90% of the time, if you use double quotes, you are good. All right, so let's break it down. When you use a special character as a literal, so a non-special character, you have to let Bash know, and there are several ways we can do that. Really, you can break it down pretty simple here. And that is if you put things in double quotes, it's going to ignore all special characters except for the $. And the $, we saw, we can reference variable values with the $. There was command substitution with that. So if you want the $, to be interpreted and nothing else, then you don't use double quotes there. And then if you want nothing, no special characters to be interpreted, then you put single quotes. Then everything in there just becomes a literal. Exactly what you type is exactly what you get. Then we kind of have like, if we want to do a hybrid of that. So if maybe you had some special characters in the echo that you wanted to be processed, but then some special characters you didn't, then we can simply integrate the / and we can escape that special character. So therefore we won't actually, get that output there. All right, here's a good example. We'll just do this on the shell here. So if I was to run date command, you can see I get that back. Now, if I was to echo, and then we'll just do today is, and then we'll just do date right here. What am I going to get back? Yeah, perfect. Catching on. So now if I go in here and I do this right here, what am I getting back? Yeah, we're going to get back the actual date right there. All right, so now if I was to, we'll just to show you the difference right here. If I was to go over here and I put date again, but this time I'm going to put a backslash in front of that, you can see now I actually get this interpreted, the date ran, but because I backslash this one, I get the literal of what I typed. Now, if I was to go back in here and do this, what am I going to get? Just the literal. Today is date right there. So, you know, if you just want literal, use that. If you need a hybrid of it, then you can throw in the backslashes and get the hybrid of it. But if you want all the dollar signs to actually be interpreted there, then you can use the double quotes. And then if you do nothing, then you get every special character. So if you do no quotes whatsoever, then every single special character, wildcards, everything is going to be interpreted on that. And oftentimes it's not exactly what you want to happen. That's why I kind of say the good rule of thumb is put everything in double quotes right there. All right, so we've got the curly braces that I was talking about. So again, and one thing I want to point out was, see a good one on that. Yeah, right here. This is perfect. So when it comes to actually creating a variable, so you can see right here, here's the variable name that I have. I said person equals max right there. Note that there's no dollar sign in front of that. And that's going to be the rule as we go throughout the semester. When we're actually assigning a value to something, there is no dollar sign. But when we are wanting to reference a variable to actually get its value, then we throw in the dollar sign. So make sure y'all pay attention to that because it comes important. We'll see it even later in this lecture here. All right, so now throw in the actual braces right there. And then what you're doing is you're creating kind of an isolation. And that becomes important. And here's an example as to why. So right here, I'm just setting up a variable called CT. Let's just, I like getting in the shell and doing this stuff. So I'm just going to create CT and set it equal to counter, hit enter. So if I do echo now $CT, I'm going to get counter. Now, if I was to then come in here and we'll just say way, and we'll set it equal. And then if I wanted to reference that variable, I say CT, and then I'm wanting to add to it. And I say clockwise here. What do y'all think I'm going to get? Well, a what? Perfect. Why? Perfect. Yeah, because right here, I got a dollar sign. So I'm saying there should be a variable called CT clockwise that actually exists. So if I hit enter here, and then I come in here and try to echo dollar way, then you can see I get nothing. I mean, it has no value. So that's not going to work. Now, if I go back here and I throw in this isolation, now it's going to look and be like, okay, there is a variable called CT, and then that is attached to only this. So this right here is actual literal right here. So now when I hit enter and I go back to echo way, you can see it's going to hit that counter clockwise there. So that kind of provides us that insulation so we can kind of glue things together when it comes to our variables. All right. And this is something we're going to see all the time through Linux. We've already seen it. So we just saw that. Now we're going to add something to it and make it a little bit more confusing. And we're going to see this brace syntax several times throughout the semester. This one right here is called string or substring extraction. One of the important things to note in here, so we have our string. So this could be a string, a variable. So we're just going to use it as a variable here. And then we kind of have these delimiters that are right here using the colon. The first one is position. You can kind of think of this as if you are referencing the index of an array. And then contrast that, how they changed it. They didn't use the same name position and this length, and we'll see how that plays out right here. So I'm going to go ahead and create the same thing over here. And we're going to call it my string, and we're going to set it equal to 1, 2, 3, 4, 5, 6, and Spider-Man. All right, so now if I echo $my string, I get the contents back. Now, expanding on it, we can do this. Again, it's going to be the same exact thing, but now we're going to throw in this kind of string splicing right here, trying to get back a substring of it. So if I just give it a 6 here and hit enter, oh, y'all didn't tell me I put in 2 4s. Y'all are supposed to catch that kind of stuff. All right, now let's go back over here. Okay, so now if we take a look, I said I gave it a position of 6 right here. So that was the starting position. So kind of just like if we're referencing an index. And what I did, I didn't give it an end. So it just kind of went to infinity. So if you look, we start at 0, 1, 2, 3, 4, 5, 6. And so that's its starting point. So it's going to start at the S and give us kind of to the infinity there. Now, if we wanted to say, okay, let's go ahead and just start at 0 index and then go to 6, then note that we get 1, 2, 3, 4, 5, 6 because it goes 0, 1, 2, 3, 4, 5, 6 exclusive. The kind of the second part, it excludes where it lands. So you only get kind of those first characters right there. And just kind of showing that it does start at 0 here. If we did 1, you can see if I do 1, we don't get 1 because the 1 index is 2. And then the important thing to kind of follow on this that is the most confusing, because why didn't they just make it both like an index? That would have been nice, but it didn't. It did length. And so this is how many characters past your starting position. So if I was to do 6, 6 here, you can see what it does is it goes and it starts at that 6th position and then counts from there 0, 1, 2, 3, 4, 5, 6 exclusive. So you get the spider there. If we went and did 8, it'll push it out when we don't get the end. And I can come in here and actually do 24 from that position. It doesn't care that there's not 24 characters.
Does that syntax work for text files? Like could you put a file and then go to line, like go this many down? Characters on the file?
No, we would have some different utilities for that. This would just be a string. So this is all it's going to work on. So if you put a file name in there, it's not going to know what to do with that. Now, if you were to like echo out the entire file and then pipe it, no, you couldn't do that. Never mind. I was off on that one. All right, any other questions on that? What you got, Levi?
Provided a length value that would make it land past the end.
I just did that on that. So like I gave it 24. We know there wasn't that many in there right there. So it just says, okay, I don't care that it's beyond the length. I'm just going to view those characters. So luckily it doesn't error around that. So you don't have to be precise. Okay, unset. Let's take a look at this one. So unset allows us to actually kind of delete a variable. There is no other command to delete it. So again, we're just going to go, I think, what did I use? Person right here. Yeah, we'll just use the same thing. So we'll echo out $person and just make sure we still got max right there. Now, if I wanted to, I could go in here and set person equal to nothing. So again, note that here reference $. Here I'm setting the value, no $. So if I hit enter and then I was to try to echo person out, it still exists. We can actually test that. We haven't hit it, but set is a command that controls or has a list of all of our variables in there. I can pipe that to grep and then look up person. And you can see there is that actual value. It exists. And again, we'll hit set later. Now, so I'm going to go back and we're going to set person equal to max again. And this time I'm going to unset. Now, just like I said, when you're assigning a value, you can think unset, I'm assigning it a value of nothing. I'm deleting it. So I don't want to do $. I only want to do $. When I'm trying to get the value of something. Here, I'm manipulating this variable. So I would say unset person. Then if we go and do echo person, you see we got nothing. If I run that set command and gret for person, you can see no white space, no nothing. That variable was completely removed from the system.
Whenever I redo set type grep after I delete person, it says person or underscore is equal to person.
Okay.
Does that mean it's
No,
it's
that's
how they-
cool. Let me see what command. Print env. Oh, I misspelled it. Print. I just killed my system. Give me a second. Really? There we go. All right. Print env. Okay. You got this, right? Little underscore right there.
Yes.
Okay, what's this? Let's see. We'll just say echo Bob. Enter. Print env. Oh, I can't do it because it's going to catch it every single time right there. So you see the value right there is user bin print env. So what is happening is this remembers your last command. And that was your last command that you did. Now, it's kind of fun right here. So let's just say I said mk directory, and we'll just do dir. And then I'm going to say, and cd into $_. See what I did? I made a directory called dir, and then I cd'd into it, and I referenced that underscore. And since dir was the last argument there to it, it remembered it and cd'd into it for me. So that's why you're getting that underscore there. Cool question. Yeah, we did all that. All right, now hit and read only. So if we want to make a variable that cannot be overwritten, we can use this read only command right here. So again, we'll just kind of look through this. Person equals Zach. We can echo it out. I set it to read only. And then of course I give it that. Again, no $ right there because I'm not referencing the value. And then you can see right here, I'm setting person equals a Helen. And then what does it do? It kind of fights back with me. It's saying this is read only right here. So then I even go farther like, okay, well, that's read only. I'm going to unset that thing because I messed up. And then look what it does. No, it's read only. So I just created a variable on my system. And actually, let's just do it. So we'll do, I think we have person equal. No, I don't have person because I had to reset. So person equals max again, and then we'll do read only here and give it person. So now we'll echo $person. We have the value of max. So now I can set person equal to, we'll do Ted. And then of course, if I was trying to unset person, I get that again. So what am I going to do? I just created a variable and I can't get rid of it. Somebody tell me. How can I get rid of it? Person mumbles. Actually, oh, well, let's try it. So we'll do this, Control A, sudo. And I remember my password. There we go. Sudo unset command not found. It didn't like that at all. Let's actually see if we could do sudo, and we'll set person equal to Ted. I didn't like that either. This is a variable. Sudo works with commands. That's kind of one of the problems right there. I've actually never tried it with unset, but the thing is it will not work. There is no command that I can do to allow me to override person. So how could I get rid of person? No. This is an underlying concept thing. We never directly talked about it, but we have talked about it indirectly. Anybody else think? Which
variables things sort of follow somewhere?
Oh, you're getting somewhere, is it?
Considering it's
It is. Did I create person in a file? Anywhere? No, I mean, anything I do in the shell, like when I create something like that, I'm loading it into RAM. So it's just there taking up some space in RAM, but there is no file. So knowing that, how can I get rid of person? What you got?
Very local variable. The variable is like. So like equals the Telegram.
Okay. It doesn't matter if it's local or global. I can make them local or global, but there is no file. So if I just go over here and we'll go back and just show you if I exit. Doesn't like me doing that. It's really wanting me to restart. All right. So now if I go here and just echo $person, person doesn't exist. I can set, type it to grep, look for person. So what does that tell you? How did I get rid of person? Or why could I get rid of person that way? Yeah, perfect. It was temporary. There is no configuration there. You remember when Linux gets all its information when it boots up and it reads the config files, right? So I just created that temporarily within my shell. And yes, within my shell, there's no way I can get rid of it, but it's only temporary. If I just reboot the machine or bring up a new terminal, I don't have to worry about it. It's gone. Now, if it was permanent, how would I get rid of it? Well, that's simple, because if it's permanent, if it's there every time you boot, it's in a config file and you just go and edit the config file and make it where it's not read only. So then when it reads that script, boom, it's no longer read only. All right, export. So that's how we make things global. So you can see I've kind of got this set up where I've got this directory path right here. I'm setting it equal to, that path. And then if I just declare export on that variable, then it's global. Nope, I could do it all in one line here. I could just say export and then give it the actual name and then give it its value. And I did it all in one line. Then it's global.
You say global, you mean like it's accessed throughout all your files?
What I mean by global, again, is the scope of the shell. And when we talk about that, we're talking about, can the parent pass the information to a child? So that's all that the global / environment variable is. It's, can it be passed down, or is it confined to just that single shell? Very, very important, because like if you have something, you run a script and your script is going to be referencing a variable. Well, if you don't declare that variable in your script, then that variable has to be global, because your script just spawned a subshell and that parent then passed all of that information, all those variables, to your script that way. And then this gives us also the power to take, some of these named variables, like if we had home right here, and I know it's supposed to be all caps, but you could actually manipulate that variable right in your script. And it doesn't matter if you declare it global or local, it doesn't matter, because it's confined to your script, because your script is now a child. It can't pass that information back to the parent. So once your script runs, home will have its original value, because it was never edited in that shell. Okay, so I just showed you two methods, read only and export. Now I'm going to show you a whole other command that can do everything those two commands can do in the same command, and that is declare. So you can see this list right here. We can declare something as an array, a function, an integer. We can declare it read only. We could declare it that is a global, which, again, export right there. So if I wanted to combine these, I could say, okay, this is read only and it's global, or I can throw in an integer right here. So I could do IRX, and then it's all three of those. And then here is the wonderful, wonderful part about Linux. And you'll see this multiple times too. So when I declare an option, what comes before the option? What designates, hey, this is an option? The dash, right? So get that I'm in here, and if I do that dash right here, I am adding the read-only privileges. So look at the fun part. We need to remove that privilege. What is the opposite of a negative sign? A positive sign. So if we want to remove it, we need to use a plus sign. Yeah, I mean, it's just Linux humor. You got to laugh. If you don't, you may cry. So we'll use an example here. We'll just do, I can't think. We'll just do a directory here. So my dir And we'll set it equal to /home/J Corcoran, BN right here. Okay, so I could do it like that, or I can use the declare right here. And then boom, that works. Here's the thing that I like in my scripts. This right here is a keyword. It gets highlighted. I think, well, I mean, it just depends on your color scheme. Oftentimes it'll be blue. And I think the one that we use. So I like to actually use that at the top of my script because then it just doesn't look like all the other code. It has this nice keyword right there that's all highlighted, and I will put all of my variables up there. But note, you don't have to do that. You can even sit here and declare, like if your variable doesn't need a value, you can just declare it beforehand where it's kind of just sitting out there. And I like to do that because that lets me know, like, I don't want to just have it in the middle of my script and not know that that variable exists in my script. I like to go ahead and just declare everything at the top, whether if it has a value or not. So that way I know to look for that variable in my code. So if we were to declare, we'll just declare num and set it equal to 2. Yeah, actually, no, we'll do this one. 2 + 2. This one's a fun one. So if I do that and then I echo $num here, you can see I have 2 + 2. Now here's the fun part. If I was to go in here and say, hey, this is an integer here, and then hit enter, and then go back and look at the actual value, because I declared it as an integer, it went ahead and did the math for me in there. So just kind of a little nuance. Now, declare has multiple functions. One is listing kind of all of these, the arrays, the functions, the integers, the read only, the export. It's all in this if you use that. Of course, this right here is kind of hard to go through. So if you don't give it an actual argument, so if I just say -I here and hit enter and no argument, then you can see it's going to give me a list of all the integers. And of course, there's one that we created. So if I was to go back up here on num, and then let's just go ahead and say plus. So we're going to remove it as an integer, and then I declare I, you can see it fell off the list. Of course, it's still there somewhere, but it's just a string now. It has no, declaration on it right there. Let's see. I think that's the only thing. Of course, I mean, all of these work right here. If you were to go through and you can see all the read only variables here. So those are all the read only. If we want to see all the global ones, we could do X. So here's all of the global variables that are being declared. And of course, you'll see several things kind of similar with the print env. Okay, this is just some of what I worked through. If y'all want to kind of see that. All right, path. Path is a very, very important variable on our system. Path is what tells the system, if I run a command, where are you going to look? Because it's actually, it just doesn't run it from the shell. It's going to go through and look and see where this is on my system, and it's going to go through in order. So whatever is first in that list, it's going to look there. If it doesn't find it, it's going to look in the next one and go on and on and on and on. This is a good example of what it should look like. Sorry, right here. But when we do it on this virtual system, because it's attached to Windows, it gets a little bit more information there. Oops. And that is once you see it hits Windows here. So it's a whole bunch of Windows stuff. So you could actually have, commands within Windows directories right there and use them. It would pick it up in here. Now, if we wanted to actually manipulate that path, and again, well, actually, we'll come back to that. There's kind of a special syntax, and I can't explain to you why they actually allow this, but this is the only place, there may be more, but it's the only place I've seen it. So if I wanted to add to path, and matter of fact, I don't want to mess my path up. So I'm going to call bash. If I call bash with no argument, we'll use $$ here. So this is the process ID. So it's the current shell that I'm working in. So if I call bash here, well, I think we get in processes on our next one. You'll notice that my history doesn't contain the same history. I'm actually in a different shell. I'm in a subshell, so it's a child. And now you can see its process ID is 413. Don't have to remember that. We will cover that next time. So now if I got in here and I said echo $path, just to verify it's there. Now let's say I want to add a path that's in my present working directory here. So we'll just say, well, we'll do sandbox. That's an existing one. So I could actually set this by doing path equals. And then if I was to go in here and let's say, we'll just say I'll do tilde slash sandbox. I think that's what I said. So if I hit that, hit enter, and then I go to path, look what happened. That's probably not what I wanted to happen, right? I just overwrote my entire path. If I try to run commands, it's not going to be good for me. Just to kind of show you again, if I'm in a subshell here, so I echoed path, if I was to exit, and now I'm in the parent, and oops, if I was to echo the path, my path is back. So I'm gonna mess with this again, but again, I just spawned a new subshell. So whatever I do, it doesn't really matter because this child can't pass it back to the parent. So I'm going to go in here and set path, but I'm gonna set equal to $path. And if we look in here, you can see the delimiters are actual, colons right there. So that's how I gave it that delimiter. And then I gave it my path. So if I hit enter and then we echo path, you can see now that was added right there. And when I say this is special, I told you before how we need to isolate that. When we saw the example, we couldn't, but because this is a special recognized delimiter, I can. In other cases, if it was a normal variable here, we would want to isolate that variable. And then I could go over here and we'll just say sandbox2 just to show you that it still works that way. So it's up to you on how you want to do that. But because of this, you can kind of shortcut it and not have to do those isolation braces. All right, your PS1 prompt. So that right there is the actual information, the prompt that you see on your system here. So I'm gonna exit out, get back to my normal shell right here. So this right here is called the PS1 prompt right here. And if we want to, we can actually manipulate that using this nifty little chart right here. So as you can see, the $$, so that is the actual $sign you get. Now you could do a literal, but this right here, because it has that anything with that /, it means it's special. So this one will allow, if you change to root, how we saw at the very beginning of the semester, when I changed to root, it had a pound. So this will allow that to happen. So it'll switch from a $sign from a normal user to a pound if it's root right there. And then of course, we won't go through all of these right here. But you can see like the small w is the path of the working directory. We definitely have that. The small h is the host name for it. And then we have the /@ So that actually is a time. While this right here, it is just a literal @ because it doesn't have a slash. So let's show you how that would work there. And I'll just pull this over and copy what's there. So if I set PS1, actually we can go ahead and echo first PS. $PS1. So this stuff right here, this gibberish, these are color codes. That's how you're getting the green right there, and then more color codes right there. So we're not going to do the color codes. Ours will be without color. So if I set PS1 and I set it equal to, we'll do that /u, we'll do the literal @ symbol, then /h for the host name. Then we're doing a literal colon, and then /w, and I can't remember what that was, but then we can do the $$ here, and then kind of enclose it, hit enter. Now you can see my prompt just changed. No color codes. And then you can see my prompt's a little bit different. It's kind of the cursor's butted right up against that. If I want to change that, I could simply give it a space. Now we could do that. If I want mine to actually have like a little smiley face, I could do that. So now it has the smiley face there. You can change whatever you want to do. Linux is configurable. You can have fun with it. We also have the PS2 prompt. So if I was to say echo $PS2, you can see it has that little arrow right there. Some of you have seen that already. So if I was to say echo, this is string, and then I don't, because I started with that little quote right there and I don't kind of end it right there, then I've kind of left it open, and you can see what it's telling me is, hey, this thing isn't closed up. It still needs some more information. So if I hit the equal sign, then it kind of closes up and gives me that print. So that right there is that PS2 prompt. So if I wanted to come in here and just say PS2 equals, we can do anything. You can do a bunch of stars here, hit enter, then I go back here. Oops. Delete that. Now you can see that changes that prompt right there. If I close it up. So not something that obviously you'd want to do, but this does come into play later on when we start writing scripts. And there are some commands that will prompt the user for stuff. And yet we could maybe create like an echo back to the user before it actually happens, or we could manipulate some of these prompts to actually be information like, hey, enter your name here. And then it would have that as the PS2 prompt and the user would know what to type. So we can manipulate that in that script. And then of course, we don't have to worry about it, messing up our actually shell, because again, it can't pass that information back there. Here's a list from the book. If you don't have it, it's not really so much important right there, just a bunch of kind of keyword variables that are in our system. And of course, you can see here's all the different prompts. We will use most of those. I'm not sure about the PS3 prompt right there. Kind of keep this one in the back of your mind. We will use it later on, this reply. It actually kind of works like that underscore does. It will hold special information that you type with particular commands. And then instead of creating your own variable, you can just reference the built-in variable in the background that captures that information. All right, let's through that. I don't want to hit anything else on this because this is kind of a big topic. So when we come back, we're going to be talking about processes, and we'll be creating aliases and our first functions. So we can actually create functions within the shell. We don't actually have to create them in the script. So we'll do that, and that will be all the topics that we have before the first exam there. Let's see. I am missing something, but I can't remember what that was. So I'll remember it, pick it up last time. All right, y'all are good to go. I will see y'all next week.